So I've got a couple of questions here for you on the scalar product. What I want you to do is read the questions, pause the video, have a crack at them and come back and check your answers against what I'm going to present to you here. So here you go. Just 3 questions for you. First, I want you to find the scalar product of 2 vectors, and I'm giving you information about the vectors and their relationship to each other. Second one, I'm giving you 3 points, and I want you to find the angle between 2 vectors that you can get from those 3 points. And then the third one, I'm giving you 2 vectors and a property, and I want you to find the missing part. So pause the video and have a ping at those. So the first question was, find the scalar product of 2 vectors whose magnitude are 4 and 8 with an angle of 45 degrees between them. So we have to remember that our scalar product, our A dot B, we're going to use the format where we have an angle. That's given by the magnitude of A, magnitude of B, cos theta. And we can read these off straight away. Magnitude of A and magnitude of B, it doesn't matter which way around we put them. So one of them's 4, one of them's 8. So that's going to be 4 times 8. That's then going to be times cos of theta. That's then going to be times cos of 45. So 4 times 8, that's 32. It's then going to be times cos of 45, which is times 1 over root 2. So in this case, we're going to have 32 over root 2. I could rationalise the denominator if it asked me to, and I'd have root 2 over root 2, multiplying it by that. What that would then give me is 32 root 2 all over 2, which I could then simplify to 16 root 2. So there you go, that's it rationalised in terms of a denominator and what I could do. I could also do that to this point here, but you know, it's just nice, quick, simple and easy to do it that way. Second question was, find the angle ACB if A, B and C are these 3 given points here. First thing to do is actually figure out the angle as a system. So do a little sketch. There's my points A, B and C, and what it wants is the angle A to C to B. So it wants the angle here. So in order to do that, what I've got to do is calculate these 2 vectors to use. So what I'm going to do is I'm going to let one vector, my little vector A, be the equivalent of the position vector C to A, and my B be the equivalent of my position vector from C to B. So calculate both of these. So my C to A is equal to the position vector of A minus the position vector of C, which we can get from just the 2 coordinates here. So that's going to be 0, 1, 6. Take away negative 1, 3, 4. Calculating those, what that then gives me is 1, negative 2, 2 for my vector CA. I then got to do the same and calculate my vector C to B. Well, that's the equivalent of my position vector B, take away my position vector for C, which in this case is going to be 2, 3, 0. Take away the C, which is negative 1, 3, 4. Calculate that, what I'll end up getting is 3, 0, negative 4. Now, I'm wanting the angle, so what I want to calculate is cos theta, which I know is given by A dot B over magnitude of A, magnitude of B. Now that I know my vectors A and B, I can calculate that, because remember our vector A, that's our C to A, and our vector B, that was our C to B. So just do each part on its own. So my A dot B, that's going to be the equivalent of 1 times 3 plus negative 2 times 0 plus 2 times negative 4. So 1 times 3 is 3. This part here is 0. This then becomes minus 8. So it's 3 minus 8. So it's negative 5. My magnitude of A is going to be given by the magnitude of this vector here. So it's going to be the square root of 1 squared plus 2 squared plus 2 squared. Just forget the negative, because when we square it, we get a positive anyway. So it's 4 plus 4 plus 1. So that's the equivalent of square root of 9, which is 3. my magnitude of b, same sort of idea, except in this case we're using this one, square root of 3 squared plus 0 squared plus the 4 squared. Again, ignore the negative because of the square. So 3 squared is 9, 4 squared 16, so that then becomes the square root of 25. Square root of 25 is 5. Plug it all together now back into this. I've got a dot b, so I've got negative 5 over 3 times 5. Simplify it by cancelling the 5s and I get negative 1 over 3. So cos theta is negative a third, which means that theta is equal to cos minus 1 of negative a third, which in this case gives me 109.47. Continues on like that. So round it to one decimal place. So 109.5 degrees. That's the angle between the two vectors. Now it looks nothing like this diagram. This here was purely so I could look at it and make sure I understood what vectors I needed and where the angle was within the system between them. Bear that in mind. Third question was find C so that Ci plus 2j minus k is perpendicular to I minus 3k. Now remember, two vectors, the property for them to be perpendicular is that a dot b equals 0. So if I label this vector as a, this vector as b, and I do the scalar product between the two of them, my answer would be 0 for them to be perpendicular. So for this one, if I do a dot b, I would get c times 1 plus 2 times 0 plus negative 1 times negative 3. So in this case, I would end up getting c plus 3. Now I know I can use this property here, so I can say it's fine. So therefore, c plus 3 has to equal 0. And for this to be the case, c is equal to negative 3. So there you go. That's the value of c so that those two vectors are perpendicular. There you go, some nice, simple, standard questions that you would get for the scalar product, things that we should know by now and that we should be able to calculate and work with when it comes to this property associated with vectors.